Hi there. Today we will discuss the principle of pressure measurement and the velocity measurement, and we will see the altimeter how it works. So first we will discuss about the YouTube manometer. This is the basic pressure measuring instrument, or we say pressure gauge. And the conventional pressure gauge we see is basically works on YouTube manometer principle. So what is YouTube manometer? Consider a tube in U shape and there is a liquid filled in it. Let's say mercury. A1 and A2 are the areas. Let's consider we have attached a pressure tank here which has a pressure P, say P1, and this side is open. So here will be atmosphere pressure P2. So there will be certain pressure difference, that is delta P will be equal to P1 minus P2 if P1 is greater. Because of that, this mercury here will rise. So let's say mercury rises to the height delta H. Now let's draw another diagram. So now here is P1 A1, is P2 A2, and the mercury rise is delta H, and this was the mean position, and the delta H is the rise in mercury column. So now the pressure difference will be equal to the pressure which is equal to the weight of the mercury. We can calculate it by the force conservation force equation. The force here will be equal to P1 into A1. This will be equal to the force on this side, that is P2 A2 plus what is the force due to mercury rise. This is equal to the weight of this mercury column, which is equal to rho into G into delta H. Rho into delta H into A2. Rho delta H into this volume, this is mass, and G is the gravitational acceleration. So this makes a weight, and that is equal to force. So now from this we can calculate the pressure difference between these two tubes. So that will be equal to P1 A1 minus P2 A2. This is equal to rho G delta H A2. Let's say now this area is constant on both tubes. So P1 minus P2 will be equal to rho G delta H. So basically what YouTube manometer measures, it measures the pressure difference, or we can say all the gauges measures relative pressure or pressure difference. So if in a question it is given that the gauge pressure, so it will be equal to P1 minus P2, that is that will be equal to absolute pressure minus atmospheric pressure. Let's say P1 is at absolute pressure and P2 is atmospheric pressure that is applied on this side. So rho gh will be equal to relative pressure or gauge pressure. Now let's see the principle of pitot-static tube and the static tube, which is mounted on the aircraft for the onboard velocity measurement as well as pressure measurement. So this is the pitot tube and this is the airflow. So the mouth of pitot tube will be aligned to the airflow but in opposite direction. Okay, so air enters here, will go, and the total pressure will generate here. This will be the absolute pressure or total pressure. So here there will be a pressure measuring instrument, digital instrument, which will measure the total pressure. So what is total pressure? Total pressure will be equal to the addition of static pressure as well as dynamic pressure. And there will be another tube which is perpendicular to the flow, and this is called static tube. This is static tube and this is pitot tube. So pitot tube measures absolute pressure and static tube will measure static pressure. So here we can see no flow is entering in this tube. So whatever pressure measured in this tube will be a static pressure. So how we calculate the velocity from this? We know what is absolute pressure. It is the sum of dynamic pressure plus static pressure. This is equal to total pressure. So we know what is dynamic pressure. Dynamic pressure is half rho v square plus static pressure, let's say P, will be equal to P naught. Let's say it is PS for static. P naught is the stagnation pressure or absolute pressure. So from this we have half rho v square equal to P naught minus PS. So V square equal to P naught minus PS by rho into 2. From this we can calculate V, which is equal to square root of 2 into P naught minus PS divided by rho. What is P naught? P naught is absolute pressure or stagnation pressure, and PS is the static pressure. So from this we calculate the velocity of aircraft or the air speed of the aircraft. Okay. So also there are two types of airspeed calculated. One is equivalent airspeed, and another is true airspeed. What is equivalent airspeed and what is true airspeed? From here we have V equal to 2 into P naught minus PS by rho. So if we keep rho equal to the absolute density at that altitude on which where we are calculating V. So if you put the density there, what we get, that will be the true airspeed. So if we calculate V equal to square root of 2 into P naught minus PS by rho altitude. This rho will be the density of atmosphere or air around the aircraft at that altitude. If we keep the local density, the V we get will be our true airspeed. So this will be true airspeed. Now if we keep a V equal to square root of 2 into P naught minus PS by rho at sea level, if we keep the density equal to the density at sea level, what we get, the value of V will be equal to equivalent airspeed. There is one another term for airspeed, which is calibrated airspeed. What is calibrated airspeed? This is same as equivalent airspeed. Little difference is there. So V will be equal to square root of 2 into P naught minus PS by rho altitude, or calibrated speed will be V equal to square root of 2 into P naught minus PS by rho altitude, or the local density Now this is equivalent airspeed, but in calibrated airspeed we correct the V for the instrumental errors. So there will be certain correction added in computer or measuring instrument that will cancel out the errors in measurement. So what we get will be calibrated speed. uh, no questions are asked in past gate examination on calibrated speed. There will be questions on equivalent airspeed or true airspeed, because calibrated airspeed, this is done by considering lots of different phenomena like temperatures, or in flow interference, etc. This will be a complicated case, so no questions will be asked. So what we have to look at is equivalent airspeed, which is rho at sea level, and the true airspeed in which rho will be used, local density will be used. Okay, fine, thank you.